Hey guys, this calculus lesson is on differentials. It's basically an easy lesson compared to what we've been doing lately, the optimizing word problem. So let's go ahead and get started, you guys. Differentials, you guys, is it's just on the AP. It's easy, basically messes around with derivative notation, and we'll get what's called error factor and propagated error. So this is what differentiation is all about. So let's go ahead and get started. Remember, dy dx is just your derivative right there. It says the derivative of y with respect to x. And what I'm going to do is take this fraction and multiply both sides by the denominator dx, and I get dy equals f prime of x dx, okay? And this dx is going to be our error factor right there. So, okay, where the change in y is the same as dy, okay? So the change in y, which is dy, you guys, equals f prime of x times dx, and that's the change in x, dx is. Okay, let's go ahead and try one. So let y equal x squared, find dy when x equals 1 and dx equals 0.01. So going to go ahead and take the derivative, real easy. So f prime of x equals 2x, or dy, remember dy equals, it always has a dx with it right here, so 2x dx, and then just substitute everything in, you guys. All right, so you plug in x equals 1 after you take the derivative, and the dx, which is your change in x, your dx, is 0.01, so you get 0.02, okay? Nice and easy. All right, so find the the differential dy of the given function. So we just have everything has a dx tag to it. It's everything we've done before, except it's a dx tag to it. So dy is just going to be the derivative is dy dx, and so this one's going to be the derivative of sine is cosine times the chain, which is 3, so it's going to be 3 cosine of 3x. Okay, and put this dx over here. It always ends in dx right there. So dy equals 3 cosine of 3x dx. Okay, told you it's easy, you guys. So this is what's called in differential form. All right, it's that easy, you guys. And so this says the change in y, this says the change in x. Okay, so let's try this one here. So y equals the square root of x squared plus 1. So dy dx is, remember, this is to the 1/2 power, so it becomes 1/2 x squared plus 1 to the negative 1/2, and then times the chain of this is 2x. All right, and then put this dx over here, put this in back in the radical form down underneath, and so we get the 2's cancel, you guys. This 2 over here cancels that 2. So the x is on top. There's my dx. I multiply both sides by dx, and that's the answer right there. Piece of cake, huh? All right, let's try one. Okay, so here's one that's called propagated air. The radius of a ball bearing is measured to be 0.7 inches, as shown in the figure. If the measurement is correct to within 0.01 inch, that's my dx. Estimate the propagated air if the volume of the ball, if in the volume of the ball bearing. Okay, so here we go, you guys. Here's the formula of a sphere. Volume is 4/3 pi r cubed, where r is the radius of the sphere. So r in this case is at 0.7, and the change in r is that plus or minus 0.01 right there. Okay, so we're going to go ahead and do the same thing. We're going to have do the differentiation. So to approximate the propagated air, we differentiate the volume. So it's going to be when I do that, don't forget you got the chain right there. So I take the derivative of this, and it always has the dr right there. All right, and the dr is going to be just your plus or minus this 0.01. Okay, and it's just substituting it in, you guys. It's that easy. And then you crank all that out, and you get plus or minus, what do we get? Plus or minus 0.06158, and it's volume, so it's in inches cubed. So the AP is asking for the propagated air. That propagated air is about 0.06 cubic inches. All right, nice and easy. If you're in my calculus class, that's your nice and easy homework assignment.